Let's take a look at some numerical data and talk about how we can organize our data into a histogram, and then talk about some characteristics of a frequency histogram. So what I have here in an Excel spreadsheet is a random sample of 147 adult females and their heights measured in centimeters. So typically in statistics, when you have or collect data, you store your data in a spreadsheet like this. But as you can see, as I'm scrolling down, this long list of data in this data set makes it really hard for us to kind of see any patterns or trends. Again, this represents the height of adult females measured in centimeters. So let's say, for example, we want to ask the question, what is the average height of a typical adult female? It'd be hard to say based on this data set when it's in a list like this. So one thing that we do is once we've collected our data, we decide on categories or classes where we can break our data into those categories or those classes. And then we, from there, start counting how many pieces of data fit into each class or each category, and that creates our histogram. So what I have here on the right is a histogram of the data that is on the left. So you can see here in this histogram, what we have done is we have broken our data into 11 classes. So let me show you what those classes are. The classes are broken up into, you can think of them as bins or categories. So how many of our data fall into heights that are between 130 and 135 centimeters? How many of our data values fall between 135 centimeters and 140 centimeters, and so on and so on. So you can see here that each class width is 5. So the difference between 135 and 130 is 5 centimeters. The difference between 140 and 135 is also 5 centimeters. So that's another unique characteristic of a histogram. We have our classes that all have the same width, and then what we do is we count the frequency, or we count, how many times we see a certain value appear in the data set. So here we can see, as I click on each of the blue frequency bars that make up the histogram, you can see that there is one data value, so one adult female who is between 130 and 135 centimeters. Okay, there are 0 pieces of data that are between 135 and 140. We have, let's see here, what is that? 2 pieces of data, or 2 adult females who are between 140 and 145 centimeters, and we can keep going. So here you can see that we have 6 data values that fall between 145 and 150, so that's our third class. We move to the next class here. So there are 13 data values between 150 and 155 centimeters. Let's move over to the next class. So the next class here are heights that are between 155 and 160, and you can see here that there are 37 data values that are in that class. And then we keep going. Here the frequency is 40. The next class has a frequency of 31, and the next class has a frequency of 10. Let's see, the frequency for heights between 175 and 180 is 6, and then 1. So when we add up the frequency for each class, that gives us the total. So here we have a total of 147 pieces of data that makes up our sample size. The other thing that I want to point out to you in regards to this histogram is we can see that, so first of all, the classes have the same width, so the width of each class is equal, but we can also see that there are no gaps between what we call class boundaries. So you can see that between each class there is a number that makes up the class boundary. So a class boundary is basically the number that we use to separate the classes, but without any gaps that are created by the class limits. So we can see here like 135, 140, 145, 150, those are all what we call class boundaries. And these class boundaries, depending on which class you're looking at, can sometimes be the upper class limit or the lower class limit. So what do I mean by an upper class limit and a lower class limit? A lower class limit is the smallest number that can belong to each of the different classes. So when we take a look at the first class here, 130 to 135 centimeters, the lower class limit is 130. When we look at the second or the third class here between 140 and 145, we can see that the lower class limit is 140. Let's move on to the next class. Here we can see that the lower class boundary for that class is 145, and so on and so on. Now, the upper class limit is the largest number that can belong to each of the different classes. So if we look at the first class here, 135 is the upper class limit. When we look at the second class here, 140 is the upper class limit for that class that doesn't have anything in it, any data in it. The third class here, 140 to 145, that 145 would then be the upper class limit. So depending on, which class you're looking at, a lower class limit can then also be the upper class limit for the next class. So for example, if I take a look at this right here, if you're following my arrow, 145 is the upper class limit for this third class from 140 to 145 centimeters. But then when we move to the next class, 145 to 150 centimeters, that number 145 is then now the lower class limit for the next class. So when we are talking about class limits, that's what we're referring to, okay? The last thing that I want to talk about in regards to this frequency histogram is this histogram is a very nice graphic or a visual of our data set, and it kind of helps us understand how the data is spread out. So how are female heights distributed? We can see here that it's distributed in a way where the shape of the distribution for our data is somewhat bell-shaped. Bell-shaped meaning that the majority of our data values, so the majority of adult females in our sample, have heights that are in this center range here between 155 and 170. We can also see that the highest frequency bar occurs at the center of our distribution. And so in the class between 160 and 165 centimeters, we can see this has the highest frequency. So most of our data we can see is hovering around this center. So to answer that question, what is the average height of a typical adult female? We can say, or we can safely say, that it's approximately between 160 and 165 centimeters. Or we can say that at the center of that, so approximately 163 centimeters, we can say that the average height of a typical adult female is most likely going to be around 163 centimeters. The other thing that the distribution tells us, so the histogram tells us, is it gives us a nice range for our data. So we can see very quickly here, which is something that was hard to see when we had the data in a list, is here we can see that female heights range between 130 and 185 centimeters, with the majority of adult females having heights between 155 and 170 centimeters. But we can also see that we have some lower frequency bars on the low end, indicating that there are some women who are a lot shorter than the typical or average female, but there aren't as many. And then again, on the right tail here, we can see that yes, there are also adult females who are a lot taller than the typical or average adult female. But we can see that those numbers of really tall adult females or really short adult females, there aren't as many because the frequency is a little bit lower.